containerized app development with Acon, Sameer Kulkarni. Okay, next, resiliency framework with Litmus Chaos. Next is deploy Go packages as deb RPM in 5 minutes. Next is how we are building our in-house Heroku alternative on Kubernetes. Sriram Venkatesh Big Binary. We have another home lab Pi cluster setup by Chetan. And if time permits, we'll do that as a last, basically. Post that, we'll have a conclusion of the event. And after that, there is Infra Cloud Bingo and basically raffle, which they are giving away Xbox. So if you want an Xbox, you can stay by that time.
My talk is on slowing down I/O disk. My name is Srijan Shukla. I work as an SRE at Last9. And yeah, I'm going to discuss a problem that I faced like a few weeks ago. The issue was that we had multiple operations running on a single disk. And it was a normal GP3 with like a 3000 IOPS and 500 Mbps throughput. But one of the operations, we wanted to have that as more priority. We didn't want other read-write operations affecting this particular operation. We didn't want any latency impact on that. So yeah, we had to look for ways to prioritize these operations. And we can't just add more IOPS and throughput because yeah, they cost more money. And even if you do add more of them, the other processes would hog up all the IOPS and throughput. And in most cases, we saw that IOPS was the bottleneck. So yeah, the things that you can do to limit IO operation speed are these options, and I'll go through them. So, but primarily there are like two things, two levers that you can control. You can either control the speed of the IO operations itself, the IOPS, or you can control the bandwidth. And with these different options, some of them you get to control both of them, and with some of them, you can only control like one of them. So in my case, I wanted to actually delete files. And when I would go on to do that, the RM command would simply take up all the disk IOPS. And if I would run the iostat command, I would see CPU wait at 100% usage, and that would affect the actual workload, which was our #1 priority. So yeah, the first option was to use the find command, get the list of files, remove them one by one, but you can add a sleep timer in between. Your script can sleep for a while. But this works for small files, because what you're actually controlling here is the IOPS speed, but you're not controlling the bandwidth here. If the file size is too large, then it will use up all the bandwidth available and not leave anything else for the other processes. The second option we have is use rsync. You can use rsync for all kinds of things like moving files, deleting files, and use it with a bandwidth flag. So it has an option to limit bandwidth, but again, what happens here is you're controlling the other thing. You're controlling the bandwidth, but you're not able to control the IOPS. So you may still end up hitting the IO operations limit. Also, the way the bandwidth flag is implemented with rsync is that after it writes a data block, it then checks whether the speed is in check or not. So if it has exceeded the limit that you mentioned, then it will just sleep for a while. So you might still experience some burst bandwidth if you use the second option. And yeah, the third option, which was Ionize, it is the most common thing you'll find online, but actually it has a lot of nuances. So Ionize I tried it and I saw that didn't work. Then I went into how to get it working. I found out that it only works with a specific IO scheduler. There are 3 IO schedulers: CFQ, NoOp, and Deadline. And it only works with CFQ. So that was one of the problem. And you'll also see CPU being completely used, CPU stuck in IO wait stage for all the time. And again, the same problem that you have with disk, you now have with CPU also. So also, I found out that I/O schedulers are not really much of a benefit when you're using SSDs. So that's another thing. And the last option was C groups. So C groups, you can do it manually. You can use any tool, or you can use a container runtime also, Docker containerd, and mention I/O limits or bandwidth. You can control both of them together. But there's some nuance with that also. With V1 and V2, like C groups V1, you will run into issues because it doesn't impose the disk limitations at the level of write back cache. So yeah, those are some things. And yeah, that's basically something I wanted to share. That's about it. And yeah, if you have a similar problem with respect to CPU, then you can talk to Vijay. I was discussing this with him yesterday, and he mentioned they wanted to slow down CPU, and yeah, that was an interesting conversation too. Yeah, thanks.
Yeah, he meant not me. So someone.